All right, let's just jump right in. Picture this. You've got a live, complex Kubernetes cluster on EKS. Everything's running, things are good, and then the email lands. The mandate from security. Encrypt all internal traffic. Your stomach drops, right? How in the world am I going to do that without blowing everything up? Well, that's exactly what we're here to talk about. We're going to walk through how to pull this off safely without causing a massive outage.
So, here's how we're going to tackle this. First, we'll talk about that zero trust mandate. Then, we'll get into the tools of the trade, Istio and mTLS. The real meat of this is the gradual rollout strategy. This is key, and I've got a great near-miss story that shows why it's so important. After that, we'll cover how you can actually prove to your security team that it's working. And we'll finish up with a clear blueprint you can pretty much take and run with.
Okay, let's kick things off with the big challenge, that zero trust mandate. And we're talking about how to do this in a messy, real-world EKS cluster, not some perfect lab environment.
This really is the million-dollar question, isn't it? How do you secure all that service-to-service traffic inside a cluster that's already live, already messy, and has been running for a while? I mean, building security in from day one is one thing, but trying to bolt it on later, that's a whole different ballgame. And let's be honest about what that live cluster actually looks like. It's not neat and tidy. You've got a bunch of different namespaces, probably for different teams. You've got some cool modern microservices right next to these, well, let's call them legacy workloads that are just blasting plain text traffic all over the place. I'm sure this sounds familiar to a lot of you, and it's into this complex mix that the mandate drops. Encrypt everything.
So with that challenge laid out, how do we actually solve it? Let's talk about the tools we're going to use to build that trust between our services, Istio and mTLS.
First, let's talk mTLS. That's mutual TLS. Now, you probably know TLS, right? It's the little lock icon in your browser. It proves the website is who it says it is. Well, mTLS takes that a step further. It's mutual. It's not just the server proving its identity. The client has to prove its identity to the server, too. Think of it like a top-secret club handshake. Both sides have to know the secret code. And this is huge because it gives us two things. One, the traffic is encrypted. And two, both services are 100% sure who they're talking to.
Okay, so mTLS sounds great, but how do you actually do it without it turning into a complete nightmare? Are you going to go ask every single app team to change their code to handle certificates? No way, that's a non-starter. And this is where Istio comes in and, frankly, saves the day. Istio, as a service mesh, automatically puts a little proxy, a sidecar, right next to each of your applications. This proxy handles all the mTLS stuff for you. Your app doesn't even know it's happening. And that's the magic right there. Zero code changes. That is an absolute game changer.
So we have our tools, Istio and mTLS. But you can't just flip a big red encrypt button on a live cluster. That's a one-way ticket to a PagerDuty alert at 3 a.m. We need a strategy. We need a way to get from where we are now to where we need to be without breaking everything along the way. It's all about doing it safely.
And this right here is the absolute key to doing it safely. Istio has two mTLS modes. First, there's permissive mode. Think of this as your transitional phase. It's like a really chill bouncer at a club. It'll accept both encrypted mTLS traffic and old-school plain text traffic. It lets everyone in. This is our safety net. It allows those legacy services to keep working while we migrate. Then you have strict mode. This is the goal. This is the bouncer with the clipboard and the velvet rope who says, nope, if you're not on the mTLS list, you're not getting in. It rejects all plain text traffic. This is how we enforce zero trust.
So, here's the game plan, step by step. Step 1, we turn on permissive mode for the entire cluster. The key here is that nothing breaks. Everything just keeps working. Step 2, we just watch. We use Istio's dashboards to see who's still sending plain text traffic. We make a list. Step 3, we go talk to the teams who own those services and help them get ready for mTLS. And then, step 4, the fun part. Once a namespace is all good to go, we flip the switch on just that namespace to strict mode. Then you just rinse and repeat, one namespace at a time. It's safe, it's controlled, it's manageable.
Okay, so this process sounds solid on paper, right? But let me tell you a quick story from the trenches that shows just how critical this phased approach really is. This is a story about a near miss that could have been a total disaster.
And it all started with something so simple, something any of us could do, a typo. Just one little typo in a YAML file. We were trying to apply a strict mTLS policy to just one service that we had finished migrating. But because of this tiny error in the selector, the policy wasn't nearly as targeted as we thought. So instead of locking down just the front-end app, that typo made the policy apply way more broadly.
Suddenly, a bunch of other services that were not ready for mTLS, were being told to reject all plain text traffic. And you know this is exactly the kind of thing that happens, right? It's late, you're pushing a change, it happens.
But here's why the process worked. Because we were doing this gradually, and because we were watching our dashboards like a hawk, we saw it immediately. A little spike in blocked requests popped up. The blast radius was tiny. Instead of taking down the entire cluster, it was a small, contained problem that we fixed in minutes. Just a blip.
And this really gets to the heart of it. A good process doesn't mean you'll never make mistakes. It means that when you do make a mistake, it turns a potential catastrophe into just a learning experience. It's the difference between a post-mortem and a quick chat.
All right, so you did it. You rolled out mTLS, nothing broke, and things are running smoothly. But you're not done yet. Now you have to go to the security team, the auditors, the compliance folks, and prove it. How do you make the invisible visible?
Yeah, you can't just walk in and say, trust me, it's encrypted. You need cold, hard proof. And the good news is, Istio gives you exactly that. Number one, you can pull up a tool like Kiali and literally show them the little lock icons on all the traffic flows. It's a fantastic visual. Number two, for the more technical folks, you can pop open a terminal and run Istio proxy status to show them the raw Envoy configuration. And number three, you can demonstrate that Istio's built-in CA is constantly issuing and rotating certificates for every single workload. That's not just a claim, that's verifiable proof.
Okay, let's bring it all home. We're going to wrap all of this up into one simple, actionable blueprint. This is the pragmatic plan you can take back to your team for your cluster.
So here it is, the complete playbook. Step 1, get Istio installed. Step 2, immediately set the mesh-wide default to permissive mode. That's your safety net. Step 3, monitor and identify. Use your dashboards to hunt down any services still using plain text. Step 4, remediate. Work with those teams to get their clients updated. Step 5, enforce. One by one, as namespaces are ready, you switch them over to strict mode. And finally, Step 6, verify and report. Keep proving that encryption is working to all your stakeholders. That's it. That's your repeatable plan.
So there you have it. Your traffic is encrypted. You have identity. You've taken a massive step towards zero trust. But it does bring up the next big question, doesn't it? Okay, so now we know who is talking, and we know no one can listen in. But what about who's allowed to talk to whom in the first place? Just because you can prove your identity doesn't mean you should be able to talk to the billing database. How do you control that? Well, that's the next layer of the onion, and maybe a story for another day.